So this is the new concept. Today we are going to learn about Demoris theorems. Now, understanding about the Demoris theorem for me, I don't think that was difficult, but the most difficult part of this theorem for me was to pronounce this thing, as I have searched a lot that how to pronounce this word, and since it is a French name and English people pronounces differently, and the French people pronounces differently. So after a lot of research, I found someone who was pronouncing it, and I don't know whether it is correct or wrong, but whatever I heard, so it is actually Demoris theorems, and it's a French name, so of course we have to say the same way as the French people say. And in English, when the English people were explaining this theorem, so they pronounce it as Demoris theorem, but it is Demoris theorem. Demoris theorem. Okay, so anyway, so according to Demoris theorem, if here we have to find the power of the complex number. So let's understand that if we all know that in the polar form, the complex numbers are written in the form of r cos theta plus iota sine theta. So if we want to raise a power on that complex number, so of course if you are raising a power on the left hand side, so you have to raise the power on the right hand side. Now applying the product rule means if we multiply the two complex numbers, and so what do we get? Let's suppose if we multiply this whole theorem, this whole number with the 2, so we have to multiply r cos theta plus iota sine theta times r cos theta plus iota sine theta 2 times. So keeping that in mind, Demoris said that what you have to do, you raise the r, that means the modulus, with the power of n separately, and here there is an angle. For the cos you have an angle, and for iota sine you have an angle. So what do you do? Multiply the angles, that means the theta, with this power. It means it will, you can write it as n theta, and over here also n theta, and this is how you have to work on this concept. So let's solve some examples and we will see that how can we apply Demoris theorem over here. So the first thing is that if any complex number is written in the rectangular form, you have to apply all the skill which you have studied before to convert it into the polar form. So in order to convert the rectangular form into polar form, the first step is that you consider that this whole complex number without the power is equals to z. So after that one, the first thing we should analyze that which quadrant does it lie. So we can see that both the imaginary and real part are positive because it is plus 4 and this is plus 4 square root of 3. It means both of them lie in the first quadrant. So if both of them lie in the first quadrant, keeping that in the mind, here the argument formula is theta. So now go ahead and find out the value of r, and the formula of r is a squared plus b squared. Whereas a in our case is 4 and in our case b is 4 square root 3. Don't write the I while solving for the b. Okay, so now here we will get 4 square plus 4 square root of 3 whole square. Don't forget to put the bracket while solving these questions, otherwise you will get the wrong answer. So here let's see in the calculator and check that what do you get. So pause the video and see that what do you get by solving. So 4 square means 16 and plus 4 square root 3 means 16 times 3, that is 64. So I guess you will get a square root of 96. But let me check. Let me check that what do we get over here. So that is 4 square plus 4 square root of 3 whole square. So you will get 8. You will get overall answer as 8. Now find out what is our argument equals to. So theta equals to, we know it is tangent inverse of b over a. So as I said to you that we have to take all the a and the b values while finding the argument as positive. Here it is by luck already it's positive. So 4 square root of 3 over 4. Keep the calculators in the radian mode while solving all the questions. Otherwise you will get a little bit different answer, and that would not be acceptable if your teacher is asking for answers in the radian form. So you will solve it and you will get 1 over 3 pi. So this is our argument. Now write down that z equals to r cos theta plus iota sine theta. Now here what is our r? Our r is 8. Cos theta, it means cos 1 over 3 pi plus iota, and sine theta means 1 over 3 pi. We replace our r and the theta over here. Now raise the power of n, and here the n and the power is 6, which you can see in the question. So if we put here z power n, we have to raise the power on the other side, so it will be whole power n, and similarly over here I can raise the power whole power 6 because our n equals to 6 according to the question. So this is our n. Now after this, while solving or while applying the Demoris theorem, what do? We raise the power, we write the r power n, and then we write cos n theta plus iota sine theta. This is the formula for this theorem. So you write 8. 8 is our r, so you write 8 to the power n. After that you will write cosine 6 times 1 over 3 pi. Don't forget to put a bracket because this whole thing is going to be your angle. Plus iota sine, and the same thing, 6 means the n times 1 over 3 pi. Now before doing anything and solving anything, find out this is 8 to the power 6. So find out in the calculator what is 8 power 6 equals to, and it is equals to 262144. Now cosine 6 times 1 over 3 pi means 2 pi plus iota sine of 2 pi. Once we are done, we are going to multiply this r from the to the inside values by using the distributive property. It means we will get 262144 cosine 2 theta 2 pi plus 262144 iota sine, or write the iota before to avoid any confusion, sine 2 pi. Now just check and write 262144 cosine of 2 pi. So this gives you, because the value of cosine of 2 pi is 1, so it will give you 26. I'm writing over here. It will gives you 262144, and if you write here, now find out 262144 times sine 2 pi. So you will get here, if we write sine 2 pi, you will get 0 plus 0 I. So the answer is 262144. So this is your answer. Means in the complex numbers, sometimes we get only the real part, or only the imaginary part, or both the parts. So they are correct. Let's solve this question. 2 square root of 3 minus 2i whole to the power 8. So the first thing is convert this complex number into your polar form. So make sure that which quadrant does this complex number lie. So you know that is plus and minus, which means that they lie in the fourth quadrant. And for the fourth quadrant, the formula for the argument is 2 pi minus theta. If you don't know how we found out this formula, please see the previous videos. And here, now find out first of all the r. So for the r, you have to convert the complex number into the polar form. So for the r, we have a formula a squared plus b squared, and it will gives you a squared, that is 2 square root of 3 whole square plus minus 2 whole square. So it will be give you 4 times 3 12 plus 4 16. So the whole it is equals to 4. So the answer for R is 4. Now find out what is theta equals to. So when we find out the theta, we don't write the B and the A value as a negative. So always, to avoid the confusion, I would suggest take the B and the A as a positive value. So B is 2 and the A is 2 square root of 3. Make sure that the calculators are in radian mode. So write down in the calculator shift tangent and then 2 divided by 2 square root of 3, and it would gives you 1 over 6 pi. So here the value of the theta is 1 over 6 pi, but since this theta lies in the fourth quadrant, so here we have 2 pi minus theta, that is 1 over 6 pi, and it will give you 11 pi over 6. So this is our argument. So the argument which we will use, it is 11 pi over 6. Now convert this into the polar form. So it means it is r z equals to r cosine theta plus iota sine theta. Now our r, replace it. Our r is 4 cosine, and our theta, don't take this theta 1 over 6 pi. You have to take the final theta which is lying in the fourth quadrant, that is 11 pi over 6 plus iota sine and then 11 pi over 6. Now we have to raise a power which is given in the question as 8. So if we put the 8 over here, we have to write the 8 over here, and we have to raise the power of 8 everywhere. Now according to Demoris theorem, we have to write the r with the power, it means write 4 with the power of 8, and now all this power will be multiplied with the angles. It means here it will be multiplied with this theta and it will be multiplying with this theta. It means cos 8 times 11 pi over 6. This one is our theta, and the same thing you have to write here, iota sine 8 times 11 pi over 6. Now check in the calculator what is 4 to the power of 8 equals to. So this is equals to 65536. Now check what is our angle equals to. So 8, make it in the calculator, 8 multiply by 11 pi over 6. So 11 pi over 6, it will gives us 44 over 3 pi, and same thing over here, iota sine 44 over 3 pi. Now multiply the r by using the distributive property inside. It means we will get 65536 cosine of 44 by 3 pi plus iota 65536 sine 44 over 3 pi. Once we are done, we have to just write in the calculator one by one to get our value. So first of all, write down 65536 cosine of 44 pi over 3. 44 pi over 3, it will gives you minus 32768. Then write 65536 sine of 44 by 3 pi, and it would gives you plus 56755.8 I. Don't forget to write the I in the final answer. So this is your answer after applying Demoris theorem. Now let's practice this question. So the first thing is we have to see that what is z equals to. So z is equals to 1 plus square root of 3i, and this both the real and the imaginary part are positive, which means that they all lie in the first quadrant, and in the first quadrant the formula of the argument is same. So find out the r. So r, the formula is a square plus b square. So our a is 1, so it will be 1 square, plus our b is square root of 3, so square root of 3 square. So if we write this in the calculator, it will give us 2. Find out the argument. So tangent, so theta equals to tangent inverse b over a, and our b is square root of 3, so replace b by square root of 3, and our a is 1. Make sure that your calculators are in radian mode, so convert this thing and you will get 1 over 3 pi. So here our r is 2 and our theta is 1 over 3 pi. Now write down z equals to r cosine theta plus iota sine theta. We raise the power on both sides because our n is 4. So our n is 4. So we raise on the left hand side as the power of 4, and similarly we raise the power of 4 on the right hand side. Applying the Demoris theorem, we have r. First of all, substitute r as 2 and your thetas as 1 over 3 pi. After doing this, what we have to do, we have to raise the power of r as 4. Sorry, this is our 1 over 3 pi. Okay, so here the power 4 goes on the r. It means you will get 2 to the power 4. Then this power 4 will multiply with the angles. It means cos 4 times 1 over 3 pi, and similarly sine 4 times 1 over 3 pi. So you will write cos times cos 4 times 1 over 3 pi plus iota sine 4 times 1 over 3 and pi. Now if we see 2 to the power 4, 2 to the 4, 4 to the 8, 8 to the 16, so it will give us 16. 2 to the power 4 will give us 16, and here we will get cos 4 times 1 over 3 pi means 4 by 3 pi. Similarly, iota sine 4 by 3 pi. Now distribute this 16 with the cos and the sine. So you will get 16 cosine 4 by 3 pi plus iota sine with the 16, iota 16 sine 4 by 3 pi. So on distribution, you write the 16 beside the cos and beside the sine. So now one by one write down in the calculator 16 cos 4 by 3 pi. It will gives you 8, and iota, and if you will write sine 4 over 3 pi, so let's see here. If we write here, let me just check that if I am not mistaken anywhere. So let me just correct my thing. So the cosine 4 by 3 pi, 16 cosine 4 by 3 pi, it will gives me minus 8, and iota sine 4 by 3 pi, 16 sine 4 pi with 3 pi, it will gives me minus 8 square root of 3. So don't forget to write the iota, and it is good if you write the iota after the number rather than before the number. And this is our answer in the rectangular form. Let's practice more questions. Let's practice this question. So in this we have, let's see that this complex number is equals to square root of 3 minus I. That means first of all we have to find out what is r. So r is square root of a square plus b square. So formula of a is the a in this case is square root of 3, raise it with the power of 2, and plus b square, it is minus 1 whole square, because minus I, so the b is minus 1, and the answer is 2. After that, we have to find out whether which quadrant does this complex number lie. So imaginary number, the real number is positive and the imaginary is negative, which means that they both lie, this complex number lie in the fourth quadrant. And in the fourth quadrant, the formula for the argument is 2 pi minus theta. So find out theta first of all, that is tangent inverse of b over a. Substitute the b with 1 and the a with square root of 3. Don't write the negative sign because it would be easy if we write the positive sign, and after that apply the formula or final formula for the argument, that means 2 pi minus theta. So in our case theta is 1 over 6 pi, which will give us in the end 11 pi over 6. So our theta is 11 pi over 6 and our r is 2. Once we are done, we have to we have to apply the Demoris theorem, which says that we have z to the power n. It is equals to r cosine theta plus iota sine theta, and this is inside the bracket raised with the power of n. So in our case, the power is 3. It means our n is 3. So write z to the power of 3. Now, how to open it? We first write the r has a power of n, and then we multiply the n with the theta. So we will get cos n theta plus iota sin n theta. So once you memorize the formula, it is just substitute the values. So let's see here and substitute the value. So our r is 2, so write down 2 to the power of 3. Then cosine our n theta. So n is 3 in our case and theta is 11 pi over 6. Then plus iota sine n theta, it means 3 times 11 pi over 6. Now 2 to the power 3 means 2 times 2 4, 4 times 2 8, and here we will get cosine 11 by 2 pi, 11 by 2 pi plus iota sine 11 by 2 pi. Now after that, just use the distributive property to open the brackets. So you will get 8 cosine 11 over 2 pi plus iota 8 times sine 11 by 2 pi. Now find out by using the calculator. Make sure that your calculator is in the radian mode, and if you have the scientific calculator or the graphic calculator, you can change your setting into the complex one and write the whole question directly to get the right answer. So let's see here, you have 8 cosine 11 pi over 2, and I am writing because my calculator is in already complex mode, so I am writing this together to get the answer directly, but you can do it one by one as I explained before, and to make sure you can just change your settings. So you will get here minus I. The reason is that 8 cos 11 by 2 pi, that will give you the 0, and 8 sine 11 by 2 pi gives you negative 1. So you will get negative I as the final answer. Now here in this question, already the question is written in the polar form. So apply the Demoris theorem. We just raise, here it is our R, this is our thetas. The angle is our theta. So we can raise the power of 4 on the R. It means write down 3 to the power 4. And now multiply the angle with the 4. So we will get cos 4 pi by 6 plus iota sine 4 times pi by 6. Now here we will get 3 to the power 4. I guess it should be 3 to the power 81. So you will get 81. Now simplify the angle. So you will get 2 pi by 3 plus iota sine 2 pi by 3. Don't forget to simplify the angles. Open the brackets by using the distributive property. So write 81 cosine 2 pi by 3 plus iota 81 sine 2 pi by 3. Now write down in the calculator to get our final answer. So we will write here 81 and find the answer, that is 2 pi by 3 plus iota sine 2 pi by 3, and that's it. So the final answer is minus 81 over 2 plus 81 square root 3 by 2 I. So this is our final answer for this question. Let's see the last question. So here I will use another ink so that you will understand. So the first part is you raise the power on the R. That means it will gives you 2 to the power 4. Multiply this power with the angle inside. So you will get cos 4 times pi by 4 plus iota 4 times iota sine 4 times pi over 4. Now you will get 2 to the power 4. You will get 16. And this 4 are cancel out. So on simplification you will get cos pi plus iota sine pi. Now use the distributive property, and to open the bracket you will get 16 cos pi plus 16i sine pi, or I 16 pi. So right here I better. Okay, so you will get here cos of pi, it's equals to negative 1, so it will give you negative 16, and you have sine of pi, it is equals to 0, so you will get 0i. So the final answer is negative 16. So I hope that this concept is clear to you. Now always remember that practice makes a man perfect. So if you practice more and more the questions, so there would be no doubt, no doubt that you will remember this theorem, and you will know that how can you apply this theorem without memorizing the formula. So see you in the next video. Thank you very much. Don't forget to subscribe my channel because I am making the videos only for you.